Yeah, today we are going to speak about the extraction of caffeine from tea leaves. And before starting the experiment, so you need to know what you need. You need tea bags.
Some Lipton there.
Lipton, yeah.
What flavor is it? Lemon.
Yeah, lemon, yeah.
Lemon flavored tea,
Yeah.
right?
Yeah. We need sodium carbonate.
Sodium carbonate. Sodium carbonate. All right.
Yeah.
So the Na2CO3.
Yeah. We need a wood stick.
A wooden stick.
Yeah, wooden stick,
Small wooden stick.
Yeah.
All right.
Yeah. We need de-water.
This is deionized water. How much is it?
Oh,
Roughly.
It doesn't matter. This one because I'm going to take some and pour.
Okay, a big beaker of it. 150 mils. Yeah.
Okay. We need here that's a container for used tea bags.
The weight, kind of waste, temporary waste.
Yeah.
Cool.
We need a 50 milliliter beaker.
50, just a small beaker.
Yeah.
Cool.
We also need a test tube.
A little test tube.
I will explain to you why I'm using that.
All right, so we got a test tube, yeah.
Yeah. We need a plastic funnel.
And a plastic funnel. All right, little plastic funnel. All right, cool.
Yeah. And a sand bath.
Okay.
Sand bath.
And right now it's cold.
It's cool. I just plug that in, but it's cool.
It's still cold. All right, cool.
Yeah.
All right. Wait, all right.
Like that.
Okay, so you're going to take the weight of the tea bags?
Yeah. I just take the weight of one because they all have the same weight. Yeah.
Roughly the same.
Yeah.
So you're going to weigh one of the tea bags.
Yeah. I just cannot put that. Wait.
I got it. You want me to?
Yeah.
Okay.
You can see that.
Alright. 2 tea bags.
Yeah. 2 tea bags. Here you have 2 tea bags. I'm going to put them on the balance. It's already adjusted at 0. I just put 2 of them.
So 4.64, they're roughly 2.3 each?
Yes.
2.3 grams each.
Yeah. 2.3 grams each. I need to write that somewhere. It's 4.64, huh?
4.64 total, and so roughly 2.32 each?
Yeah.
2.32 grams each.
Yeah.
Oops.
Okay. Now, you take this beaker, you have sodium carbonate, and you need
carbonate, yep.
1.5 gram of sodium carbonate.
So you're going to put 1.5 grams of sodium carbonate into the small beaker.
Yeah.
Cool. Do you want to bring the beaker?
Yeah, it can fit on the balance. No problem. Let's check. Yeah, it fits. Yeah.
Put the beaker right on there. And
yeah. Bring that back to 0. $1.5 I need. little. Just a small amount because it's a
Yeah.
1.29.
Yeah,
Okay,
good. 1.5 grams.
1.5 grams.
Okay, cool.
Yeah, I will add 20 milliliter of de-water into the beaker.
Okay. 20 milliliters of your deionized water.
Yeah. I add first 10.
First 10. Alright.
And then 10 more.
10 more.
Then I need my wooden stick, which is that. That's here.
Yeah,
And
mix
that's
it,
too
mix
fat,
it
yeah.
while heating it.
Yeah. The water has to boil.
Alright, so that's heating up. Okay.
Yeah, just the water has a high boiling point. Huh?
Yep.
So boiling, the water is boiled. We need to dissolve all the sodium carbonate.
Alright, so it's heating up. It
Yeah.
looks like it's starting to get there. That's good.
Yes.
Yeah, it looks like it's heating. You know.
You see, I can touch. That means that it's not really
Uh-huh.
hot. Yeah.
Alright, so
To
we'll
bring the water to boiling.
keep heating it.
Yeah.
Okay. You gonna say?
Yeah, we use sodium carbonate to convert tannins into the salt in such a way that the salt are going to stay into the aqueous solution.
Okay. So the carbonate's a base,
Yeah.
and it'll kind of react with the tannins, which are acidic or something maybe.
Yeah.
And then basically it keeps those tannins out of the organic layer
Organic
when
layer.
you do your later extraction.
Yeah.
Yeah, that makes sense. So, and that's why we need to have it nice and dissolved.
Yeah.
So it works really well.
It has to boil. So now we have to spend that on the board.
Okay.
So,
I'll explain the board too. Cool. Yeah, looks like it's
Yeah.
getting there. All right.
Yeah.
All right. Stirring it up a little bit.
Mhm.
It looks like it's almost dissolved there. It's
Mhm.
good. All right.
It is completely dissolved, as you can see. What you do, take that out of the pan back. That. You get the tea bag.
All right.
That's the tea bag.
Yep. Now we make tea.
Yeah. You immerse that. Immerse it. You use
Test tube.
test tube. Immerse that.
Smush it up.
Yeah. So you make sure that you don't crack the tea bag. That's how you do that.
Alright, whoops. So it's nice and it looks pretty dissolved for
Yeah.
certainly like the way
Then
the color of tea.
go like that.
Wait. So now you have the smaller Erlenmeyer,
Yeah.
and now you're gonna pour the liquid from the
Yeah. Push a little.
yeah.
Push.
Kind of
Don't crack the
pushing
bag.
down on the bags so
Yeah.
the tea comes out.
You go again.
Smash it up.
Yeah.
Try to.
Gently with finesse.
Trying to get as much of that liquid transfer it over.
Yeah. Once it's done, tea bag goes to a temporary waste.
Temporary waste beaker.
Yeah.
Alright.
Now what you do, you level the water until 20.
So right now how much? 15?
15.
So you're going to add 20 total?
Yeah, you level that until 20. Yeah. Okay, put that at 20.
You have about 20 total now?
Yeah. Okay, go back.
Keep cooking.
Yeah. And you wait.
Okay. The sand is still hot from before.
Yeah.
Yeah.
I did not turn that off.
Yeah. So we're gonna cook it more. How long do you cook it?
Well, it has to be hot, but it's not going to take too much time.
A couple minutes. Just as hot again.
Yeah, yeah.
Okay.
No,
Okay.
it's hot enough.
So we heated it up for about 5 minutes,
Yeah.
and it's probably pretty hot now, yeah?
Very hot, yeah. Start. First thing for safety.
Turn off the sand
off.
bath. You don't want to burn down the lab
Yeah, yeah.
by leaving the sand on.
Yeah.
Alright, so the sand's going to start cooling down.
Yeah.
Now you have your hot solution.
And you take your second tea bag.
You get the second tea bag.
Okay. Take that.
Alright.
Immerse that.
And put the second tea bag in the same solution.
Immerse it.
Trying to get it's a solid liquid extraction, right?
Yeah. Do that. Yep.
Trying to get more of the stuff in there.
Yeah.
Are the tannins the colored? The black stuff? Or is that, I don't know.
No, I don't think it's that. Just because that leaves.
Yeah. Oh, it's the leaves. Yeah. Okay. Chlorophyll and stuff like that.
You have a pigment too. Huh?
Pigment. So now you're trying to just remove all of the.
Yeah.
That's for the waste essentially. That you're smashing down the bag, and that's going to go in the waste eventually.
Yeah. So I go here a second time.
Trying to extract it out as much as you can.
Yeah.
Third time.
So I put that here. That's the tea bag. But the rest
Yeah.
here, I just put it here.
So you put everything into the one thing, yeah?
Yeah.
Which is roughly about 20 mils now.
Yeah.
Roughly. Okay. Cool. So you pour everything into the Erlenmeyer.
Yeah.
Okay, and that's where that's most of your product right there. Yeah.
Okay.
With impurities. Yeah.
Yeah. You can speak the caffeine. Go first. The 6-member ring.
Drying caffeine. Yeah.
Yeah. And 5-member ring. Okay, so like that. You have nitrogen. CH3. Here, like that. And this one here.
Double bond in the middle.
Yeah. That's here, and
Right.
that's caffeine. You can see that caffeine does not have any aromatic ring.
No aromatic ring.
No.
Yeah. Do you want to write caffeine there? Just
Yeah. Oh, on the top. Huh?
Yeah. All right, we got some caffeine.
Yeah, and this nitrogen are
Yeah.
basics.
And the nitrogens are basic.
Yeah.
Yep. Cool. Especially I think the right side ones.
Yeah, yeah. Yeah.
They're not talking to the C double bond O thing. But yeah, it's a basic molecule. Yeah. Okay, cool.
Now, tennis. So they are stir. Gallic acid.
Gallic acid.
Acid
Yeah.
and glucose.
And glucose.
Yeah.
So it's gallic acid and glucose
Yeah.
combined to make an ester linkage.
Yeah.
Do you know what esters are from the lecture?
So here's gallic acid.
Make some space.
Yeah.
So that's gallic acid.
That's
Yep.
gallic acid.
Yep. Cool.
Okay.
All right.
So and glucose. That's glucose here. Okay. So
So the gallic acid is kind of connected from
with one
the
of OH
from the carboxylic acid linkage
Yeah.
to
and
like
OH.
that oxygen.
Yeah.
So
Okay.
do you know which OH? Or is it just some of the OHs?
One. It doesn't
One of
matter.
them. One of them. It doesn't really matter.
Yeah. Yeah.
So one or a couple of these OHs
Yeah.
are connected. So like that oxygen
Yeah.
would be connected via an ester linkage
Yeah.
to the C double bond O.
Yeah.
And then there's no OH at that point. It's just a C double bond O connected to oxygen, connected to CH2, blah blah blah.
Okay. What you have usually you have acid plus alcohol again stir
Yeah,
plus water.
yeah.
And that's it. You have that. We are going to have That's the ester. But, oh yeah, that's also right there. So,
Yeah, so like a ester linkage between
yeah.
basically in this case it's from the C double bond O to the, like that, maybe that oxygen or something. So that oxygen would be connected to the C double bond O.
Yeah.
And when they form the bond, of course you lose water, like OH and H. So
Yeah, you have that.
so water is a byproduct.
Yeah.
Yeah.
Okay.
Cool.
So now, say that we use sodium carbonate, and I say that sodium carbonate does convert the tannins into the salt in such way that they are going to stay into the aqueous solution.
So it cleaves the ester, I think.
Yeah.
Yeah.
We also say that tannins are phenolic compound. Phenolic compound, you see,
Yeah.
here you have that. That's the phenol here.
Phenolic, yeah, it's like a based on.
That's the phenol.
Yeah.
Okay, when you look at like that, you have the phenol.
3 phenols.
Phenol, yeah.
Yeah.
So now they can be hydrolyzed. I will first go with the phenol. If you have a phenol, you wrap that with sodium carbonate. We're going to have minus sodium bicarbonate.
Yeah. So it looks like an acid-base reaction.
It is an acid reaction, it is.
So the carbonate is a base.
Yeah.
The carbon CO3 minus essentially. Oops. CO3 minus is like a base.
Yeah.
And it takes the proton off, leaves behind a negative charge,
Yeah.
and then
And you have sodium bicarbonate.
as
and
a impure or byproduct. Yeah.
yeah.
Cool.
And this one stays into the aqueous layer.
So under basic conditions,
Yeah.
the phenol gets stuck in the aqueous.
Yeah.
And that's good because you want to get rid of it.
Yeah.
It's like an impurity. And that, you can imagine that happens here too with gallic
Yeah.
acid
Now
because you have 3 of them.
for the acid, this
Cool. So it looks like the same kind of things happening
Yeah.
with the carboxylic acid. It reacts with the base
here.
and forms this thing. I think it's called a carboxylate, I think.
Yeah.
Carboxylate
Which
is
basically
just like
salt,
a salt of a carboxylic acid,
Yeah.
and then NaHCO3.
Sodium bicarbonate.
Yeah.
And here is the salt. That's also salt coming from the phenol,
Yeah.
which I will call phenolate. That's a phenolate.
This one. Yeah, and this thing's called sodium
Phenolate.
carboxylate. Sorry, carboxylate. Let's just write carboxylate. Carboxylate. Sodium
Yeah.
carboxylate. Yeah, and then
that's one.
and then phenolate.
Yeah.
Phenolate.
I think in the lecture we will need to know that.
Eventually, yeah.
Yeah.
Phenolate.
Good.
So,
Yeah.
so phenolate refers to the sodium salt of the phenol,
Yeah.
and then carboxylate refers to the sodium salt of the carboxylic acid. There's a negative charge right there and a positive charge right there.
Yeah.
And I think the key thing is that the carboxylate and the phenolate are both water soluble. They like to be dissolved because they're ionic, and that's good because you're trying to get rid of them.
Yeah.
It's like an impurity. You want caffeine. You don't want this.
Yeah, I don't
stuff.
want it
Yeah.
to go to the organic layer. I don't want that.
Don't want that. All right. Cool.
Good. So now we are going to move to the next step. So that's with 25 milliliter round bottom flask. We need to take the weight.
Did I get the weight of the flask?
Yeah. Get the weight of that. So that to zero, you just do like that.
4.23 or 4.229?
Yeah. 4.229.
4.229.
You are going to perform the extraction in the hood. The extraction of methylene chloride in the hood, because you are not authorized to handle the methylene chloride at the benches. That need to be done in the hood.
Because the methylene chloride is toxic, and
It's toxic, yeah.
and we just don't want to inhale it and stuff. So
Yes.
PM Hood's a good place.
Yeah. That's it. The first thing we do, separator is one on.
And it's closed, right?
Yeah,
Closed
it's
it?
closed.
I always have to close it.
Yeah, yeah. I did.
You make a big mess.
Yeah. That.
Alright, there's our... That's our aqueous layer, yeah.
Yeah. So because I did add more water, on the lab manual it's written 15 milliliters of water, but I went with 20 milliliters of water, which means that I'm going to extract with more methylene chloride.
So you can use a little bit more methylene chloride.
Yeah.
So instead of...
I will do a pre-extraction with methylene chloride using each time 5 milliliters of methylene chloride each time.
So 3 times 5 is 15.
Yeah. So, as I say, I have a beaker labeled methylene chloride. I pour methylene chloride into a beaker.
Cool.
It's more comfortable like that. Close. Now, I'm going to add from the beaker to add 5 milliliters of methylene chloride. Okay.
5 milliliters.
5 milliliters of methylene chloride. So, okay, then I add
And I think they remember from last week or whatever that it's on the top or the bottom.
Yeah. So even this week, okay, we use methylene chloride to extract caffeine from the mixture. We use methylene chloride, which is an organic solvent, because caffeine is an organic compound. And as you can see here, okay, methylene chloride layer is the bottom layer. In other words, the organic layer is the bottom layer because methylene chloride has a higher density than water.
Higher density, yep.
Yeah.
And I think we Yeah, I think it's 1.2 or something like that. So
Yes.
greater than 1, so it's
Yeah.
about 1.2.
So this one, you just cannot shake, because if you shake that, you are going to have emulsion.
You can't shake it
Yeah.
because it'll emulse, so it'll
Yeah,
turn into soap basically.
Like that.
Yep.
Okay. You ferment.
Yep.
Do a second time like that. Like that.
And you're venting from the top. That's a good idea.
Do a third time.
So you don't want to shake it because it'll turn into like a soapy
you're going to have a lot of emulsion and
emulsion.
that's bad.
Yeah. So we just invert it 3 times.
You need a spatula. Oh, let's explain why you need that.
Okay, so you got, what did you get? A spatula.
A spatula.
Little metal spatula. You'll use that in a few minutes, yeah?
Yeah.
Okay.
So now I will do the first extraction. When you extract, you need to open the top.
Yeah.
It's very important. Then you do the first extraction.
Drain off the bottom.
Yeah.
Trying to avoid getting the top stuff in.
Yeah.
Because that's the junk.
Yeah. And then I'm going to do the second extraction, and I will add 5 minutes of methane fluoride. I have some rest here. I just do like that. And this one. Close it. No shaking. Vent.
So you invert it and vent from the top.
Yeah. One time.
Second time.
Vent. Third time.
Third time.
Vent.
Yep. Put it back.
Put that.
Cool.
Extract.
And you stop before the black stuff gets in.
Yeah. And now I'm going to do a third extraction.
Third extraction.
Yeah. I will add 5 milliliters of methylene chloride. Close it.
And do it the same exact way.
Same thing. Down. And vent. 1, 2, 1, 2. And vent. And last time. 1, 2. And vent. Put that back. Now open. Extract.
And you extract. Third extraction.
Third extraction.
Stop.
Okay. So now here you have your organic layer containing your caffeine, but the organic layer is still wet.
Yep.
Because that was mixed with the aqueous solution here.
So there's a little bit of trace water.
Leftover. To remove this leftover water, I will need to use a drying agent. The drying agent I'm going to use is magnesium sulfate anhydrous.
Anhydrous magnesium sulfate.
Yes.
Cool. So it's basically a solid that is anhydrous and
Yeah.
it absorbs water.
Yes.
So, yeah.
So take my plastic funnel, like that.
Alright.
Now I'm going to add 2 scoops of
So you're using the funnel so you don't get it all over the place.
yeah.
2 scoops coming out.
That's the drying agent that has to be closed.
Alright, so now you have your methylene chloride and drying agent and hopefully caffeine
Yeah.
in there. And the salts at the bottom.
Yeah.
So it now should be dried. Yeah. Okay, cool. That's why you brought the spatula over,
Yes.
so you could do
That can
get your
take-
stuff in there. Yeah.
So now the next step will be what is called gravity filtration. Gravity filtration.
Gravity filtration
Yeah.
to remove the salt, right? Yeah. So you get a wing or a filter paper.
Good.
Got a filter paper. Nice.
It's a folded one.
And a funnel, glass funnel.
No, that's in a beaker. You see, I put that in the beaker.
You put this is the final, a final round bottom flask
Yeah, in a beaker.
for
to
your, you can rotovap later.
Yeah,
And you're gonna put the funnel in the flask,
yeah.
put the paper on top,
Thanks.
and pour it all in there. And look at that, all the salt's gone. And the salt should be in the top now, yeah?
Yeah.
Let's see. Let's see.
You see the salt
There's
here?
the salt in the paper.
Yeah.
Alright.
It's here, let it dry. Then you close that.
Now you're going to cap your flask.
Cap the flask. You see? Cap it.
Yep.
And the next step is the rotary evaporation.
Cool. Which they did last time.
As we did last time.
Yep. Right.
So here is the rotary evaporator. The first thing you do,
Put your
and you see the small part of
Yeah.
a plastic joint clip. Okay,
Yeah.
it's always on the top,
yeah.
like that.
Otherwise you'll break it.
Yeah. So you gently bring that
Yeah.
down.
Gotta get the dry ice.
Yeah. You add some dry ice.
Alright. Get the dry ice going.
Some dry ice.
Alright, so it's cooling down.
Yeah. Now you start the rotation. You turn on the pump,
Yep.
and the pressure will decrease. Pressure is in millibar.
Pressure's millibar.
There is no need to heat the water because methane chloride has a low boiling point, that's 40 degrees Celsius. So,
Yeah. So sometimes you would heat the water,
yeah.
but you don't need to do that today because the methylene chloride is really low boiling and
Yeah.
very easy to rotovap off
Yeah.
compared to like.
And you see, it's going to
yeah.
it's going to come soon. We're going to see the dripping. You
Yeah.
see? You see that it's already coming here.
So do you see? No, dripping. Look at
Yeah,
that.
the dripping are already coming.
So the vapors are heating or they're traveling. The vapors of methylene chloride are traveling through this, up through, touching the cold surface, and we see some dripping. So this is the methylene chloride
Yeah.
going away into the waste. That's the waste container. So seems like it's working, huh?
Yeah.
So eventually all of that's going to be gone and you're going to be left with semi-pure caffeine. Hopefully.
100% correct. To say semi-pure because I
Semi-pure.
just crude product.
Yeah. Yeah, there's going to be a little bit of junk in there.
Yeah.
But you can't assume that it was going to be pure, but it's going to be pretty pure. Semi-pure. How's the dripping going? The dripping is good. It's dripping.
Yeah.
Nice and fast.
Yeah.
And dry ice is good. You might want to add a little more dry ice. Maybe.
Yeah, I will.
You don't want to run out of dry ice.
Yeah.
Alright. Nice and cold. Do you know the temperature inside there? The dry ice temperature is about -80, I think.
Yeah, negative 80, yeah.
-80 degrees Celsius.
Yeah.
So it's pretty cold. Pretty cold.
And it does burn well.
And it burns your hand.
Yeah.
So when you grab onto the dry ice, it gets really cold. So if you touch it, you should either wear like thick gloves or a paper towel. If you use a paper towel.
So this one is called dry ice, and that's a solid CO2.
Solid CO2.
Yeah.
Yeah. So it's pretty cold. You can always grab it with the.
And you know, at room temperature, it does sublime.
The sublimes, yeah.
Yeah.
So
because it's stable at -80 degrees Celsius.
Yeah. Yeah. So it goes straight from solid to gas.
Gas, yeah.
Alright, so it's rotovapping and the solvent's coming off.
And you still have some.
A little bit left, yeah.
Oh, yeah.
Yeah, some sort of dead insect in there, maybe a mosquito.
Yeah. They're also dead.
Yeah, there. Still a little bit of liquid in there, yeah?
Yeah. I'm going to just
A little bit of heat, maybe?
Yeah.
About 50 degrees Celsius. That'll force off the last little bit. So basically done. You have the residue is in there.
Yeah.
Okay.
Okay. And you bring that up. Like that.
Lift it up.
You stop the rotation.
Stop the rotation on the left and the heat on the right.
You stop the pump.
Cool.
You release the pressure.
And it's a little. It's
Okay. This liter here of your caffeine. You see this white stuff, that's your crude caffeine.
Yeah.
Okay, that's your crude caffeine. You see here.
Let me see it closer.
See?
So it's, yeah. There
that's
it
your
is.
crude caffeine.
Not a lot, not a ton, but there's not expected to be a ton.
Yeah, because caffeine is just 5%
Yeah.
of the tea leaves.
So yeah, that's the normal amount. Yeah.
Yeah. So you turn that off.
All right.
To have the wind. You don't expect too much. That's already at 0.
Yep.
About that. Here's your good caffeine you see here.
Yeah.
You just do that.
So you can have a, yeah.
It's 42.33.
42.33. You can go figure out the percent then, yeah?
Yeah.
42.33. Oh, you got some.
You have 0.4 gram.
0.4 gram, which is about 40 milligrams, yeah?
Yeah, 40 milligram of crude.
40 mgs of the crude isolated product, yeah.
Yeah, caffeine.
So it's caffeine plus a little bit of other stuff, but for the most part it's fairly clean. Yeah.
So, now we go to the road. So, as you can see, you just have 40 milligram of isolated crude caffeine.
40 milligrams.
40 milligrams.
Yeah.
So that's crude caffeine. That's
Yeah.
not pure caffeine. To have pure caffeine, you need to purify.
Yeah.
But you don't have enough.
Yeah.
Okay? You have two possibilities to purify the crude caffeine. You can use a solvent. In this case, that will be a recrystallization method. Or you can do sublimation. You can purify using a sublimation method, which is dangerous because the best way to do that is not to use a Zan bath, but you need to use a Bunsen burner.
Bunsen
burner
burner.
to do that. So I will explain about recrystallization during the lab lecture.
Okay, so your two options you said are recrystallization, where you just recrystallize it. You pick the right solvent and then it crystallizes. Or the other option is sublimation, which is a nice way, but it's a little dangerous.
Yeah.
And
it's not as accurate as recrystallization.
Okay, so either recrystallization or sublimation, and you'll talk about recrystallization in the lab lecture.
Yeah, recrystallization and sublimation, both.
And sublimation, you'll talk about both. Okay,
right.
Cool. But it worked. I think it's just it's crude, and but you did isolate something. You got 40 megs of the crude caffeine.
And you should know, and you should be aware that caffeine, that's just 5% of the tea leaves. And
yes, it's expected to be only about 5%.
Yeah.
Because if it was a lot, you wouldn't even be able to drink the tea. It'd be too much caffeine.
Okay.
Cool.
Okay. Don't forget about tannins, which are instead of gallic acid and glucose.
So the tannins are an ester linkage from the C double bond O of the gallic acid to the OH of the glucose. And that was removed.
You have an acidic group here, and you have 3 OH group here.
Yeah.
Can be seen as a phenol group.
Yeah.
You use sodium carbonate, okay, to convert the tannin into a salt in such a way that we are going to stay in the water solution.
Stays in the water.
Yeah.
Because it's ionic. It's O minus. And the carboxylic acid also stays in the water because it's ionic.
If you don't do that, they will also go into the organic layer.
Yep.
They're also soluble in methylene chloride. To prevent that, okay, you convert them into their salt using sodium carbonate.
Yep. So that helped in the purification.
Yes.
So if you didn't use the base, those they'd go into the methylene chloride layer, and then you would have a mixture of that stuff also.
Yeah.
And that's no good. You don't want that. You're trying to avoid impurities. So
I don't want with tannin into the organic layer, which is in our case the methylene chloride layer.
Do not want the tannins in the organic layer. That makes sense.
Yeah.
Okay.
That's very important.
Very important.
Thanks to me.
Okay. Okay.
I will repeat that over and over. whenever you are done with the rotary evaporator, you need to clean it. The first thing you do, take that, the receiving flask, that's the receiving flask.
Ah, it's being stubborn, huh?
Yeah, keep on out.
There you go. You got it.
So, you empty that. Rinse with acetone.
Rinse with acetone.
Yeah. Twice. The first time.
First time
And the second time.
and second time. Yep.
Then you also need to clean the bump trap. Bump trap.
Clean the bump trap.
Yeah, which is that. Twice
Oh.
with acetone.
Yep. 'Cause you don't want to leave your residue for the next person.
Yeah. First time. Second time.
Good.
And you put it back.
You put it on
And we don't.
and you clip it on. So there's a
Yeah.
little clip,
Yeah.
a black clip. And you also have to make sure you didn't leave the
Turn
power
that
on.
off. Yeah. Then that's on. Off.
Yeah, never leave
And
your
you're done.
stuff on.
Yeah.
Yeah. And the pump is off,
The
obviously.
pump is also off. Yeah.
Where's the switch? It's right
So
there.
here.
There it is.
Yeah. That's on. That's off.
On off. Cool. All right. Good.